When we talk about the flow of fluid, traffic, or people in a network, we're usually referring to the amount of fluid, traffic, or people that can flow through a network. The maximum flow refers to the maximum possible flow that can occur through the network. A directed network can be used to model the flow of fluid, traffic, or people. In this video, we'll look at what maximum flow is, we'll look at finding the maximum flow, then we'll look at the exhaustion of all paths algorithm to find the maximum flow. The maximum flow involves finding the largest movement possible through a network. The start node is called the source, and the end is called the sink node. The network should be directed. Arcs are labelled with the maximum possible flow rate along the arc called the capacity. The entire network is broken into individual paths, and it's determined how much can flow through each path. The network's maximum flow is the total of each path. Examples include water flowing through pipes or traffic flow through a system of roads. Imagine water flows through this network from the source to the sink. We're not interested in the individual sections of pipe, but rather the rate at which water can flow through the entire network from the source to the sink. This is called the maximum flow of the network. There are three possible paths that the water can flow through this network. The first path we'll look at is across the top. 11 litres per minute can flow into node A, but 15 litres per minute can flow out. Since there's only one way in and out of A, the maximum flow for this path is 11. If you think about it, more water cannot flow out of A than is flowing into it. The second path is directly from the source to the sink. 16 litres per minute can flow through this pipe. The final path along the bottom travels through B. 10 litres per minute can flow into B, but only 7 litres per minute can flow out of B. B could be a restrictor, or the pipe from B to the sink could have a smaller diameter restricting the flow. Whatever the reason, the maximum flow of water that can flow to the sink along this path is 7 litres per minute. Now we can calculate the maximum flow through the network by adding the individual paths. The total flow is 34 litres per minute through this entire network. To find the maximum flow through a large and complex network, we can use an algorithm. In this video, we'll use the exhaustion of paths algorithm. The first step is to choose a path through the network and find the arc along it with the smallest capacity. Record this number as the maximum flow for that path, and we subtract this number from the capacities of every pipe along the path. The new numbers represent the remaining capacities of each arc. Repeat step 1 for each remaining path, recording the maximum available flow in each case and updating the capacities remaining. Add the recorded maximum flow of all paths. This is the maximum flow of the network. The exhaustion of paths algorithm requires us to consider a number of different paths through the network. It's therefore helpful to choose paths in a systematic order. I like to go from the top to the bottom usually, but it will depend on the question, including where the source and the sink are. Let's find a maximum flow of this network from source A to the sink F. The first path I will follow is A to C to F. It has a maximum flow of 3, which is the smallest capacity of the arc from C to F. We subtract 3 from the capacities of every pipe along the path, cross out 6. The remaining capacity from A to C is 3, which was 6, take 3. We'll cross out 3. From C to F, this arc has no further capacity, so we write 0. We can't use it anymore. The new number represents the remaining capacities of each arc. The next path is A to C to D to F. The smallest capacity arc on this path is C to D and is 2. This is the maximum flow for the entire path. Now we cross out 3 and take 2 from it, and we get 1, which is the new capacity. We cross out 2 from C to D, and we write 0 because it no longer has any capacity. We cross out 7 from D to F. We write 5, which is the remaining capacity. There is no more capacity out of C, so we can no longer go through C. The next path is A to D to F. This has a maximum flow of 3, which is the capacity of A to D. Cross out 3, and we write 0. Then we cross out 5, and we write 2. And we can no longer go from A to D because we've used up all of the capacity of that. The next path is A to B to D to F. This path has a maximum flow of 1 restricted by B to D. So we cross out 5, and we write 4, and we cross out 1, and we write 0, and we cross out 2, and we write 1. We can no longer go through B to D the only remaining path is A to B to E to F. It has a maximum capacity of 2 due to the capacity of B to E. So we cross out 4, and we write 2, we cross out 2 and we write 0, and we cross out 5 and we write 3. Now we add up the flow of all of the paths to determine the maximum flow of the entire network, which is 11. The sum of the smallest capacities of all the paths is the maximum capacity of the network. Let's look at another example. We want to know the maximum capacity from A to H, which is the source to the sink. The first path we'll look at is A to B to E to G to H. E has the lowest capacity of this path of 8. This is the maximum flow of that path. So we cross out 10 and we write 2, and we cross out 8 and we write 0, and we cross out 15 and we write 7, we cross out 13 and we write 5. The next path is A to B to D to E to G to H, the maximum flow of 2. That is all that can flow from A to B. So we reduce the capacity of all of the arcs along that path by 2. The next path is A to C to F to G to H with a maximum flow of 3. This is the remaining capacity of G to H. Reduce the capacity of all of the arcs from A to C to F to G to H by 3. There's only one final path, that's A to C to F to H. The maximum flow is 8. We reduce all of the arcs capacities along that path. There is no further paths because we have no capacity across the top and no capacity along the bottom. The maximum flow of this network is 21. So in summary, in this video, we've looked at what the maximum flow is, finding the maximum flow, and then finding the maximum flow using the exhaustion of paths algorithm. Thank you.